Are you able to log into the Zoom meeting? And then kind of monitor? There we go. Okay. All right, welcome. This is 2240. So hopefully everybody is expecting to be here in 2240. Oh my, this is like Oh, lovely. Okay. All right, so need another chair. This is up to. Okay, so Canvas page to start with. Hi, I'm also Angela Rasmussen, so I'm your instructor for this semester. Brittany, you want to wave? So Brittany is our grader and one of the TAs, so she'll be here when she can. She's going to help with the learning activities when we do them also. And so in this class, we are going to learn more about the linear elements that you've already learned about. If you've taken 2280 first, then you've learned about nonlinear elements. If you haven't yet, then you're going to expand what you know on 1240. So we're going to focus mostly on the AC portion, where in 1240, it was mostly DC, where you were introduced to the AC portion. So this whole semester will be pretty much AC. And we're going to learn more in-depth techniques on how do you actually analyze these circuits now with these time-dependent elements that are in there, even though they're still linear. So that is what we're going to focus on. The book is free, so make sure you get the book. It's free. So download the book if you haven't yet. So this first link here, this where it has the link, if you click on this, it's going to take you to this page. And then if you scroll to the bottom, you're going to see the one that says Circuit Analysis and Design. That is the one you are going to want to get. So just click on the free download, fill out the form, and make sure you have that accessible. If you want a hard copy, you can pay the $75 for it and order it through them if you want. So either way, just make sure that you have the book. The link that I have on the front page underneath this is self-assessment. So the nice thing about this link is that they will ask you questions for each chapter. So if you want to go and do a review and say, do I know this information? You can go here and click on, say, chapter 2, and you can try and do any of these problems. I'm going through this. So dependent sources, we are not going to focus on in this class. We will focus on dependent sources in 2280. So you either already saw them or you will see them. So everything we're going to do will be independent sources in this class. So any problems that do have dependent sources, you can skip them for now. Make sure in 2280 you go into those in a lot of depth and really understand them in that class, where it makes more sense because you model one of the nonlinear elements with a dependent source. And so that's where it makes more sense to understand those in more depth. So any problems that have dependent sources, feel free to skip those on your self-assessments. And then the nice thing about this is, say I make a guess here and it's like 4 amps. Oh, sorry, it's incorrect. You can then click there and show the solution on how they got it. So this will help guide you on studying for your homework and then also for your quiz. So this is one of the places to practice. Yes.
This is the self-assessment.
So this is for the whole book. So this, I just clicked on chapter 1, but for every single chapter, it will have in there these self-assessments. And then when you refresh the page, it comes up with new problems.
Yeah. Are they graded?
Yeah. And they're not great. Well, they give you a grade, but they're not going to count towards your grade, but you can see if you're getting credit or not. So this is from the book itself that will have these. So these will be a little different than sometimes the questions I ask. So I have another one that's a self-assessment that will give another way of practicing. That will be my questions. It's not quite as nice as this, where you have to restart the whole thing, but you can redo them as many times as you want. So practice, practice, practice is what you're going to hear again and again and again from me. And so this is one of those locations that you can be able to do that practice. So I put those on the homepage. So right when you come into the Canvas course, you're going to see those on the first couple links there. All right, so that's where those are going to be. Underneath this link will be the schedule for the semester. And I don't know how this is going to pop up. It's not too bad. So over here on the right side, it shows you the reading. So that will be the reading that I would suggest. So the first one has a lot because this is all of your review. So from these beginning chapters, go back and do those self-assessments from chapter 1. if you've forgotten, go back and look at the exercises in that chapter on reviewing on how to do that type of a problem. And then try the self-assessments again to make sure you do have the fundamentals down there. If you are transferring in, you may not have been taught the same way. So going back through the book to kind of become familiar with that is another way to know, as a transfer student, do I know the material I need in this course? Okay, so that will be where you're going to fill in gaps depending on your background of what maybe also in your previous class, you may not have hit it as hard and maybe not make as much sense. So you may need to go review that to make sure you have that fundamental. So as we move on, you're feeling really good about that material. Okay, so the first section is going to be all of the reading from chapters 1 to 6 and 7. And then what we're going to start in here is chapter 5. So chapter 5 will be our first unit of material, and then chapter 6. So our first 2 units will be chapter 5 and 6. As you can see here, some of the sections will be skipped. So this is just 5.1 to 5.5. And then the other sections you can just skim through. Some of it is like application notes and some interesting things. So if you have interest, do read it, but don't feel like you have to feel like you're mastering that material. Okay, but from 5.1 to 5.5, you do need to master that material. 6.1 to 6.8, again, you'll need to master that material. So the self-assessment for those chapters will be helpful to give you practice problems. And then what our normal schedule will be, it will look like homework and assignments will be due every Thursday. And then I usually have a quiz on Friday. So that will be set every week. It will be due by midnight of each of those nights, but do plan ahead. I do suggest even like after classes on Mondays, try and start the homework. What you're going to want to do is the homework you can attempt 5 times. And so, you know, the first time you can look at it, get an idea of what you need to know for it. And then you can go through the practice problems that are in the unit material, and then the self-assessment, which is going to be not scored, but give you areas of practicing it to become efficient on that material. Make sure you studied well before you take the quiz on Friday. You'll get 1 attempt at the quiz and it will be graded partially, but partial points, but it will give you automatically, like if you get 100 points, you'll get 100 on there. All right. And so as you can see here, each week we'll have, this week there'll just be assignment this week, which is a week 1 discussion. So every week there'll be that discussion section. And for the discussion, you're going to ask a question about what is not making sense to you, and other people then will be responding to it. So that's what the discussion is about. So you want to submit something and then also answer something from somebody else that makes sense to you, and how does it make sense to you? So that's going to help you learn, in that you're going to have to explain it to somebody else in how it makes sense to you. So that's been a helpful thing that I think has helped students learn the material also. So those will be every Thursday, that discussion. And then this week is only just to tell me more about yourself. And then next Thursday will be that discussion and homework. You'll have 2 assignments. One will be an RC problem and one will be an RL problem. And then your quiz on Friday will be either an RC or an RL. And so you will want to prepare for those. Yes. No. So quizzes are online. They will open up at 8 o'clock on Friday, and then they will close at midnight on Fridays. So you have all day to submit that. You can do it before class. You can ask questions in class and then go and take the quiz after class. But they are available all day on Fridays, and from 8 a.m. to, actually, I think I even opened them up for Thursday night, even if you feel ready for them and want to take them Thursday night. I think at 5, I started setting them a little earlier. So if you want to take them late Thursday night, and then it will just be due before midnight on Fridays. Just don't procrastinate. That's the better thing. So I've had students that sometimes take off Fridays and work all day, but I know we have class here Fridays. So I was like, okay, I'm going to set that for every Friday. So it will be the same schedule every week. And hopefully that consistency will help too. The only weeks that are going to be a little different is on midterm weeks. So on this one, you can see that you're going to have this exam 1 group individual discussion. What that's going to be is every day, which will be Tuesday before exams that are on Wednesday, you will have needed to work with your group. And if you choose not, if you're like, I absolutely hate working with a group, that's fine. You can work it as an individual also. I do encourage the group work. It seems to help students to work in groups, but if you're adamant that you want to work as an individual, that's fine too. Either way, I think it's here. On your page looks a little different than mine. You're going to be able to get to this exam group. And so if you guys have, as you meet people in here and as you meet other people in lab, feel free to form your own groups. I started it. It looks like a couple people registered after I started this. So you'll want to move yourself to a group with your other group members that you already like. So there are some already formed. If you come and look on this and want to try and find the people here in class so you know who they are, feel free to do that. Or you can reach out to them and get more information, like where do you usually sit? Or there's some empty ones that have 0 students in them. You guys can move yourself as a group of students to one of those. And then those that are adamant that you don't want to work as a group, put yourself in the individual work group there. And you can add, and if that gets full, I'll let more people in there. But typically, I've found students do work together as groups. So there's usually a few individuals that are like, nope, I am very individual and want to work in that as an individual. And that's fine too. The assignment will have specifications for the group and specifications for the individuals. Individuals usually have to do a little bit more work. So that's the other reason of doing it in a group. So you usually just have to do one more extra problem as an individual. And as a group, you only have to do one problem. So it's just a little one. What this is creating an exam. So you are going to come up with the types of problems that will be on the exam. So you will create the problem and then solve it and then submit it to the group. The group will check your work and then you'll also check the other people's work and see how they did on that. And so that's what that group discussion is about, is like, okay, here's a fictitious problem that might be on the exam. You know, did I do it right? And then go over other problems that others have done. Okay. So that tends to help people study. And again, if you're like, nope, that's not really for me, but you just need to do it, just create a couple problems with solutions and you post those. All right. Any questions so far about any of that? Okay, so I kind of jumped ahead. The syllabus will be where the grading is distributed. And on here for this, Brittany, you'll upload your info on here too. So the TAs and the grader will upload their information on this underneath the TA grader location. So you'll also have when they have their office hours and how to contact them. And then underneath mine, you can see a link to my advising page. So if you want to create a individual one-on-one appointment with me, feel free to. Otherwise, my office hours will be Monday, right before this class, 9:30 to 10:30, and then on Wednesdays after this class at 11:45 to 12:45. But I have a lot of other times because I do academic advising also. So if you ever need any academic advising, career advice, I do that too. So feel free to make an individual appointment, either coursework or advising academic plans, anything that goes along with that. So if you don't know that, I am the director of our advising and mentoring team here. So that's why I also do some of the advising for our students. So feel free to ask me any questions, whether they be coursework or academic, career related, anything like that. I'm always happy to help. All right, so my phone number, I'm also available through Teams. If you have the Teams app, you can reach out to me on Teams, either with the chat, and I get those messages too. And now I guess with Navigate You, so my appointments are just being changed over to Navigate You, but I think there's a chat feature in Navigate You too. So as far as I know, you can reach out to me through text with those also. All right, so 2240, we rely on math 2250. And so partial differential equations, I know you loved it, right? And so it's recommended that you take that either as a co-requisite or as a prerequisite for this course. So if you have not taken that yet, you might want to really heavily consider swapping over to 2280 if you haven't taken 2250, but I think you had to have had that to be able to register for this course. So either be registered for it or have already taken 2250. All right, I went through the course schedule. It's also located on this syllabus again too. And then as far as grading, the grading is going to be those assignments that are due every week, assessment and quizzes. So 5% goes to those assignments that are weekly. Homework is going to be 8%, and then quizzes are going to be 12%. I know life can be challenging and things come up often, so I drop the 3 lowest scores for assignments, the 2 lowest scores for the homework, and the 2 lowest scores for quizzes. And so I don't do anything late. I don't accept late work. Instead, you'll just get to drop that. And so that's why there's that many times in there, because I know things come up. And so no late assignments are accepted in here. Exams are going to be 75%. There'll be 3 exams. Each one will be 25%. My final is optional. And if you want to do the final, it is a retake option for the midterm. So it does a direct, whichever one you have higher between your midterm and your final retake, you can use that score in that exam grade. Does that make sense? Okay. I think you guys have seen that with other classes so far. All right. So no makeups are accepted. And again, do I accept late work? Okay. So the only other exception is if you have accommodations already set up. And so if you have some accommodations that are needed, please let me know as soon as you can, just so that, and don't worry about reminding me before exams or quizzes if you need additional time. If that's part of your accommodation, just let me know. And I sometimes just need reminders to make sure it's set correctly in the system. All right, any questions so far about the schedule, grading? Okay. So learning now. So you can go through the start here, the resources and the tech help, contact me, go through all those on your own. Pretty self-explanatory. The lectures are going to be, as you see, I'm kind of recording on this. And so these will be posted. So for those that are attending remotely or online, the online students will probably be watching these later. And so remote are those that are on right now. And then situations come up and you need to have this online at some point, feel free to attend remotely. If you get sick, I highly encourage you just to attend remotely. Please don't get others sick. And then if you're so sick you're in bed, watch the recordings later to catch back up on the work. Okay, so I try to make everything accessible so that you can get the content of what we discussed in lectures. So those are located in this section under modules. There's this lecture section. So if you click on the handouts and lectures, you'll see over on the right, there'll be these video recordings. So after, like tomorrow is when I usually will post those, if I remember later today, but a lot of times I get busy. So the next day I'll get those posted. So they'll be in the video recording section on the right here. And then by the end of the week, I typically will post notes once a week. And so you will also have the written notes that we'll go through here in class. And so again, those will be accessible. The lecture notes, I recommend downloading those or printing them out if you like physical versions before class, and then write on those during class. They're going to have all of the schematics already drawn out, so you don't have to redraw all of those. So it does save you a little bit of time and energy. I also usually include summaries on there, so those are nice to have. Also at the top of this, you can see this equation table. This is going to be really important to use as you're solving the problem. So you're going to want to always have that one really handy. So I try and keep these located in a location where you're like, okay, this is where all the notes for this unit are located. At the bottom of this, these are the previous year's lecture materials. So again, if something happens to the recording and you're like, oh, I need this information, you can go back to my previous years and go through those. So these are all on the past video lectures. All right, as far as the other learning material, we are going to start in Unit 1. For every unit, there's going to be this overview and learning materials section. And it will go through the objectives of what we want to achieve in this section. And then there'll be an overview where, again, this goes through practice, practice, practice. So there's going to be the list of chapter sections that I'm going to want you to read. So that will be under the learning material readings. And then the book link again. There's also videos from the book themselves, but I find them very boring. And they're like 45 minutes to an hour, so they're super long. So it's hard to find just the little chunk of sections that you really want. And so unfortunately, these recordings are also going to be this hour long, so you have to kind of fast forward them, but you can usually fast forward and see when things start to happen and then slow it down and then go through. So they're a little easier in the daily ones to find information, but those are available if you don't like to read at all and want to listen to it. Those would be another supplement to be able to watch. So my suggestion is for new material, you're going to go through each of these sections that is in this learning material. And I would pace yourself. So you're going to see today, we're going to go over capacitors and inductors. So kind of go back through that material. And then on the schedule, you can see kind of what's coming up. We're going to do RC and RL. So you're going to want to start studying that material. And that is where I have broken down the contents into smaller little sections so that you can get them easier. So there's going to be this little video. This is understanding floating node and voltage difference. So this is a really important concept here. So make sure to go back and review these little demo that I do and try and make sure you're understanding these concepts. And then under capacitors, it shows you, the goal of understanding the characteristics of a capacitor, that it stores voltages and releases it. It's time varying. You also cannot change it instantaneously. So these are different examples of the concepts themselves. And then these are some problems that I have solved that you're going to see. And so you're going to want to watch these and really understanding capacitors, and then the same thing for inductors. And you're going to go through both these two sections. And then separation of variables is what you're going to need from the math concept. So this goes back to a Khan Academy description of this and kind of goes through the process of that. So if you have your math book too, go back and remember separation of variables, because you're going to need that to solve the problems. And then also understanding exponential functions and the unit step functions. So those are going to be the two functions that usually are not as familiar to students. So really understanding those two concepts. And then RC circuits will be, again, these are more examples. Once you understand the beginning concepts, and then RL examples. And then second order linear equations is again another math concept. And then we're going to jump to RLC circuits. And so you're going to want to watch all those videos on each of those sections. So depending on how you learn, you just want to know yourself and how do you learn best. So some of you may be like, okay, I'm going to take these in small chunks today. I'm going to look at capacitors and spend a couple days on capacitors. Then inductors, let me spend a couple days on inductors. However you learn, others are like, let me see it all, get it all at once, and then go back and review and review and review it again. So whatever way is your learning style, you have to figure out for yourself what is your best way you learn. And so this is all the material that you're going to learn for the whole first unit. So that is all in one location. And then you want to just figure out for yourself, set your own schedule of how do you want to try to learn it all. In this section, I have all the examples, and then I also have links to previous review material, which is going to be circuit analysis techniques. So you're going to need to know very surely KVL, KCL, and node voltage. And I love node voltage. So we're going to see node voltage, node voltage, node voltage. It's going to be pretty much how I solve every single circuit. So understanding that technique, equivalent circuits, knowing how to condense down circuits, parallel series, and how do you combine them. And then Thevenin equivalent. And again, in Thevenin, it's only the independent sources are the ones you're going to need to know how to do Thevenin equivalent. Okay, so those are the review material that you're going to want to make sure to cover. All right, at the very bottom of this, I have taken out little snapshots of the tentative schedule. So if you see, and I know somebody was telling me that there was like 3 lectures for today on Zoom. So on the calendar, sometimes it messes up. I have no idea how some of those Zoom things got on there. So I deleted them all yesterday. So it was hopefully only 1 Zoom link on there today. But on the calendar, there'll be the Zoom link to this meeting. And then also on there, there'll be the reminders for when the assignment and the quizzes and the homeworks are due, and then when your upcoming exam is due. But sometimes those are in error. So if you're like, I thought this was supposed to be due then, let me know. I do make mistakes on that. So do reach out to me and let me know like, oh, I saw this. Canvas email is going to be the best because I prioritize going through those. If you send me email to my just angela.rasmussen@utah.edu, I go through that very regularly, but I prioritize the one on Canvas. So I'll make sure to go through that a few times a day to make sure that I'm answering those quickly for class. All right, so I would recommend doing Canvas emails first. All right, any questions so far? Okay, you guys ready to jump into some material? Okay. All right, so. All right, so capacitors. Anybody want to take a stab at what your understanding of a capacitor is? Yes.
Charges or it's energy through an electric field and it's slowly builds up voltage over time, so it can change current instantly.
Mm-hmm.
Pretty much.
Great. So key things there, it cannot change instantaneously. So if I put on, go down. So I equals C dV dt. Okay, so you're going to need to memorize this equation for the capacitor. So current through the capacitor cannot change instantaneously. So current cannot change instantaneously. Okay, can voltage across the capacitor change instantaneously? Yes. So I can put a battery on a capacitor, measure it, can be 9 volts. I can take it off and put a 12-volt battery, measure again, it's going to be whatever the new battery value is. So I can change that voltage by changing out a battery on it. But the current measuring through it cannot change instantaneously. So if I put a 9-volt battery on the capacitor and I let it sit there for a minute, it's going to charge up to 9 volts. So if I take off the battery, it's still going to stay 9 volts across that capacitor for a second and then slowly discharge till it's totally back to 0. The current through it, though, when I first put it on, the current takes a second to start to charge up because it is described by the change in voltage over time. So right as I add it, it's still 0, but then right after I add it, it starts to charge up and will start to change in current. Okay, so memorize this equation. You're going to see this again. Memorize equation. So with, so that's pretty much the takeaway for capacitors in the beginning. Inductor. You find the inductors. All right. Okay. Inductors. Anybody want to take a stab at describing what an inductor does? Yes.
They store energy in the magnetic field, just as how the capacitor stores in the electric.
Correct. L di dt. So memorize this equation for the inductor. And the voltage in an inductor cannot change instantaneously. Oh my goodness, can't really write there. So with this one, is a little hard to visualize. Like it's easy with a capacitor, like, oh, I can take off battery and put on a battery. Inductors are a little harder to put on and take off current. And so visually it's harder to see, but it acts the same way in that you cannot change it instantaneously. It takes a minute to have the voltage change across it. So what stays consistently is that the current, which is supplied from the external circuit, can change instantaneously. So I can change that current, but I can't change the voltage. So again, memorize this equation. All right, and then these just describe more about them. Okay. So now we're going to get into a little bit more details, but I got to get my notes for this one. Sorry. Lectures. Here we go. Oh, I know what else. Okay. So another way to look at this is just by the equation itself. So if I have, sorry, D backwards, di dt is 0, what does that mean?
Constant current across.
Okay.
The current isn't changing.
The current isn't changing. And then VL will go to 0 if that's the case, right? So if there's no change and it's sat there for a long time, there's not going to be any change with the circuit. There's nothing to make it. So yes, thank you. It becomes a short circuit with that. So we're going to model an inductor, if it's been sitting there for a long time, as a short circuit. And that is why, because there's no change, that derivative goes to 0. What about for the capacitor? So if I have no voltage change over a while, current goes to 0. What does that look like? An open, correct. So we're going to model the capacitor when it's sat there for a long time as an open, and an inductor when it's sat there for a long time as a wire. So those characteristics are what we're going to use to actually solve the circuits. The other thing we need to know is, like, I'm sure you don't want to do a separation of variable every time you look at a circuit. So we're going to look at a generic circuit, and we're going to start with an RL circuit. And we're going to see, can we look at this and come up with a solution without having to go through the whole derivation every single time. So we need to first derive this though. So I'm going to make an assumption that I have a more complicated circuit that I have made a Thevenin of and created a VTH and an RTH of it. Remember, that is the Thevenin equivalent of any complicated circuit. It can be boiled down to one resistor and one battery. So VTH will be my Thevenin voltage of that circuit, and then the RTH is the resistive Thevenin of it. And those are going to represent the complicated circuit and have the same characteristics to give me the same current out of here. So I am going to put on an inductor, which looks like this, on this Thevenin equivalent. So now I'm going to do put, across this will be a voltage VL. And then I'm going to label this as the same direction as my current, which I'm going to call IL. So when I take a voltage loop, remember for voltage loops, I'm going to start somewhere and I'm going to take a pathway going in this direction. So I'm going to go around the loop. I'm going to start in a place and go back to that place. I always suggest for students circle your polarities as you go. So that's why I also labeled the plus and minus across the resistor. So as I go through, I like to circle the second one I always come to. So as you can see here, I circled the plus on the VTH, the minus on the RTH, because that's the second one, and then the minus on the VL. So now when I write this equation, it's plus VTH minus, what am I going to write there for my voltage? Correct. IL RTH or RTH IL. And then minus, that's voltage, right? When I just labeled it as VL. So minus VL equals 0. And that's going to be my loop. And now this is where that memorization comes in, because I said memorize this equation. So this is where it comes in. VL is equal to L di dt. And now I'm going to substitute that in for that VL. And you can see here, I have a differential equation. So VTH minus IL RTH minus L di L dt equals 0. And I have now variables DIL and then DT, and this is where the separation of variables can come in. So if I separate these out, this becomes 1 over L. Yeah. And then I can integrate both sides by taking the dt to separate it out to the other side. So this is where that separation of variable technique comes in. And so I can integrate both sides from, 0 to t. When I integrate IL, actually I need to recall another property. So recall first that du over au plus b is equal to 1 over a natural log au plus b plus c. So with that, I can, oh, sorry, I need to do one more. So I need to bring, I have IL. So I need to bring the ILs over. So this becomes 0 to t of DIL. And then IL RTH minus VT. And that becomes 0 to t of 1 over L dt. So then I can use this property and it becomes 1 over RTH. I'll highlight here. So this becomes my A and this becomes my B. So 1 over RTH natural log RTH IL minus VTH. And then it will be from 0 to t, 1 over L, and then t minus 0. And then to get rid of the natural log, we have to take E. But before that, remember when you have natural log of A minus natural log of B, that is also the natural log of A over B. Yes, sorry.
So you're solving this using like derivatives in the integral way. You did a formula on your slides too, also where you just use like the initial state,
That's what I'm getting to. So this is showing how I get to that solution. And then from there, we can use the shortcut. So that makes it nice. But first of all, you need to understand where that even came from. So that comes from setting up this equation, having a differential equation, solving that differential equation. And then you're going to see that, well, if I can always reduce these circuits down to a Thevenin equivalent with the inductor, we can solve it this way. No worries. Okay, so I'm going to take E to both sides. And then that's going to, wait, 1 over RTH, sorry, I'm going to move the RTH over to the other side. So that becomes an RTH up here. And then the E and the natural log will cancel here. So I just have RTH IL of T minus VTH. And then well, let me back up. Let's see. Rory, take it away. Okay. So let me make this go RTH over here. And then this becomes E to the natural log, and then plugging this in as RTH IL of T minus VTH, and then a minus RTH IL of 0, and then I'm going to divide that over because it's a minus. So then that's why I put this on the bottom of IL of 0 minus VTH. And then this is just E minus RTH of T minus 0 over L. And then I can divide, this will cancel, and then I can divide this over to the other side. So I have RTH IL of T minus VTH is equal to RTH IL of 0 minus VTH times E raised to the minus RTH over L T minus 0. And then solving this for IL of T, I take the VTH over to the other side and I divide by RTH. So that would get rid of those two. And then plus RTH divided by RTH becomes IL of 0. And then VTH minus, or VTH divided by that RTH. And then E to the minus RTH over L, T minus 0. So this is a final value for the current. If I assume that that inductor becomes a wire, yes, sorry.
Does the E at the end also have to be divided by RTH?
So I divided it by the constants in front of it. So it would be RTH IL of 0 times E, and then divide that one by RTH. So that RTH over RTH cancels, and then VTH over RTH. Does that make sense? Okay. So if I assume this is set for a long time, and that becomes a wire, the current there will just be VTH over RTH. Do you guys see that? So that is called my final value. And then this is an initial value. And again, minus the final value. This component here is called tau. And it's called a time constant. And it's actually, this is 1 over tau, where tau is L over R. And so the final form of this, we'll call this the general form. Is going to be, I'm going to just say x of some t, and then it will be your final value. No way I divided that, but final value plus initial value minus the final value, e to the minus t minus 0 over tau. So this is our general form solution, where if we can make the circuit to look like that, where we have a Thevenin and then just one inductor. Yes.
In most scenarios, yeah, I don't really like, I feel like part of us to go over that.
Okay.
Like a U of T on the outside or anything.
Uh-huh. So a unit step, where can I draw? Go here. So U of T is a unit step function. What it looks like is before time 0, it's off, it's 0. So nothing is happening before time 0. Right at time 0, an event happens, and then after that, it passes at, like, it's basically just says it's on, it's 1, and it will be considered on. This is the graph of a unit function, U of T. So if I have a switch in a circuit, there's an event that's going to happen right as a switch changes. That will be modeled by a U of T function. So I'll want to draw that circuit before the switch and then after the switch. And then after the switch, everything with it, I just say has U of T because it happens after a switch event.
Okay.
So we use that U of T to model what may be happening physically. Does that make sense? Okay, so that's what the unit step function and why you kind of want to look at it. You don't really have to do anything math. All it means is that I had a switch in there, and now after time 0, it's going to be valid. So we'll use that to put on at the end where we have U of T. When we get to Laplace and Fourier transforms, you're going to also understand, like, why do you want to say that? And so that will make more sense there too. But for these first circuits, we're going to look at switches. And so first thing, understanding general form equation. And then we're going to start looking at how to analyze with the general form equation. So you can do the same thing with the derivative for a capacitor in there. It's going to be the same thing. It's going to introduce with the capacitor a derivative. So this brings up something that if I have more than one capacitor or inductor in it, every single one of them will bring in a derivative to it. So if I have 3 capacitors, 2 inductors, 1 capacitor, I have a third order differential equation that you have to solve. And that gets to be very, very difficult. So we're going to find techniques, like nobody wants to do this by hand every time. And so we look for shortcuts as engineers. And that's what we're going to do, is look for these shortcuts. For this one, this is like, okay, if I find this circuit where I have the Thevenin of it, 1 inductor, now I can just skip through and find the final value, the initial value, tau, and then put it into this equation. Yes.
That example you just did is in the first degree.
So this would be a first degree where we have just 1 differential equation or differential portion in it.
So with that, like in 2250, there was the strategy we learned to solve those equations. Can we use that same process, like the 7 steps, to get the same answer, or should we do it in the way we do it here?
So you can use any techniques. So there's other ones besides probably the one you learned. So I don't know exactly what are you referring to as far as the 7 steps?
Like there's, in which case, like with that equation, you get both of the ILs onto the IL and the IL divided by whatever else on the one side. And you leave the VT, say, on the other side. And then you use that to get like a P of X and a Q of X.
Oh, yeah. Okay.
and solve
Yeah,
that.
so those are when you have a forced, so you get the homogeneous equation solution, and then you get the forced function solution. I think those are maybe the same names or P and Q, whatever they name them now. It just means like you do it when you have no source, and then when you have a source, you get a solution. So that's what it physically now means. When you have I think the P is when there's nothing, when it's zero equal to zero, and then Q, I think, is when you have like, and for us, those mean no source there, and then when you add a source in there. And so you can solve it, it's pretty much the same way. We're going to get to that more when we get to the second and third orders. And then we'll go to partial fraction expansion, and that's when we'll use partial fraction expansion. And I think that's more what they do in 2250. But yes, I mean, you can use any of those solutions to get there once you've set up the equation, but it's much simpler to now look at the circuit and say, can I find a final value, an initial value, and tau, and then just automatically write the solution. So that's why we're going to skip right to the end of finding these final value, initial value, and tau. For a capacitor, let's see. For a capacitor, tau is going to be a little different. So in the notes I will post, I'll have the solution for the capacitance, doing it the same way. And then the difference is that tau for capacitor, it's going to be same form. So you'll have the initial and final value, and then the tau in this case is RTH times C. So that's where your difference is that you have RTH times C. So you're going to need to memorize the general form equation and the taus. So I'll put memorize. And by memorize, I mean just make sure they're on a handy sheet next to you. So for a while, it's going to take you a minute. So tau for an inductor, memorize this one. It is L over RTH. And then memorize the general form equation. Okay. So next time we're going to start looking at circuits and how do we find that initial value, final value, and tau. And then we'll start plugging them in. Yes. Yes. So quizzes are open anything. The only thing they are not open is neighbors and peers or online tutors. So no help from others, but anything you find on your own is valid. And then you can use online computers if you want. I mean, like online calculators to do the solutions, like Wolfram does them, Symbolab. So you're welcome to use those. I just ask you to take snippets of what you put in there because sometimes you enter them wrong, and add that to your submitted work. And then you can get partial credit if you make an error on something like that.
You can't use computer for exams.
No, you can. Yeah. So some students, so I'll tell you up front, some students program, like the CE students in here like to program. So you may want to create little scripts in MATLAB or even Python, whatever you're comfortable with. And even if you don't program and want to create those, they're nice to make little scripts of like, what is my R value? What is my C value? And this would be my value if they plug those in. And you just include that snippet again of your code in your submitted work. And I will ask you questions you can't always do on the computer. So there will be concept questions in there, but yes, you can use the computer if you want. The only thing is simulators. You cannot use a simulator. Yes.
So when we've got those two tau values right there, with RTH, just down a little further, those are correct, right? Technically are the final equations.
Yeah, so this general form equation.
Yeah.
Yep.
Are these technically the general forms for VT
Yep.
and IT, and then those are your tau values, correct?
Yep.
Okay,
Yep.
just making sure that I follow that
So
correctly.
yeah, so this is going to be your final value, initial minus final. Yeah, yeah.
So I just want to make sure that I associate those correctly.
Yeah.
With those same counts.
Uh-huh.
Thank you.
The other tower equation that you were doing for capacitors real quick?
Yes.
Awesome, thank you.
All right, thanks. All right, thanks for joining today. During lecture, for those that are online, just please put in the chat any questions that you have, or you're welcome to voice your questions as we go. I will try and have a person monitoring here, or I will try to monitor the chat. Thanks. Have a great day.
Thanks.
Hey, Brian.